Today we're going to take a look at the first part of section 9.1, which is on composition of functions. So we're going to start with something that we're familiar with but haven't done in a while, and that's evaluating a function using different values or expressions. All right, so use the function below to simplify each expression. So we're going to take a look at f of x equals 17 minus 3x squared, and we're going to evaluate these three expressions using that. Okay, so think about if I told you to find just f of 2. If I said find f of 2, that means replace every x with a 2. So to find f of 2x, what we want to do is replace the x in 17 minus 3x squared. We want to replace that x with a 2x. And now it's just a matter of simplify as much as possible, creating a new function. So now we have f of 2x is equal to 17 minus 3 times 2x is 4x squared. And now multiply by that negative 3, and we're going to get 17 minus 12x squared. So this is the result of doing f of 2x. Okay, so I want you to take a moment and try to do part B and part C. So pause the video and try to do part B and part C. Now for part B, to find f of x plus 2, we're doing the exact same steps. We're taking 17 minus 3x squared, and in place of the x, I'm going to write x plus 2. To simplify this one, I'm going to need to FOIL out this right-hand side before I distribute. So we're going to have 17 minus 3 times x plus 2 quantity squared comes out to x squared plus 4x plus 4. Now I want to distribute that negative 3. To get minus 3x squared, minus 12x, and minus 12. And then combine like terms. I'm going to write my answer in standard form, but it's not really necessary. But I'm going to write negative 3x squared minus 12x, and then 17 minus 12 is plus 5. Don't worry about trying to factor or anything like that. Your goal is just to have a standard form function. All right, and then for C, we're going to have f of x squared is equal to 17 minus 3. Instead of x squared, we're writing x squared in there. So I have x squared squared. All right, so rules of exponents says you need to multiply those two exponents together. And then there's no like terms or anything like that, so this is our final answer. Okay, so when you're evaluating a function by plugging in a different expression, every time you see an x, you're just writing parentheses and then filling in that expression and then simplifying from there.